So algorithms are very powerful tools, especially in today's 21st century. What exactly is an algorithm? Well, there's a lot of definitions, but the simplest one is actually offered by a very famous book called Introduction to Algorithms, also known as CLRS, named for the authors of the book. The authors are really instrumental in a lot of the new um, definitions and concepts and topics that they discovered and invented, such as a lot of complicated data structures and other algorithms in general is still used very much today. This book is often used as the defining book for a lot of algorithms and computer science, but in the end, the algorithm is just a way, a lot of computational procedures or steps that ultimately give taken an input and do some computation, do some manipulation, do some changing, and then return an output. So an algorithm is essentially just a sequence of steps, rules to take something and turn it into another thing. You already know so many algorithms. The algorithms range from very simple ones to very complicated ones. For example, a simple algorithm you have used probably is, just sorting numbers, which is a very common thing we can do in computer science. If you have a list of, a couple of numbers, you can choose which one is the smallest, which one is the biggest. Just go read through the list, pick out the ones you want, and just repeat. A lot of these algorithms have a lot of basic computer science elements embedded into it, such as loops, conditionals, relational expressions, and a lot of other concepts. But again, an algorithm takes in an input, has some sort of rules that it executes on the input and returns an output. Again, you can range from simple ones. There's also a lot of variety in the efficiency of algorithms, which is a really cool topic. There's a whole literature on that, but some algorithms are very simple, but they're very inefficient. It takes a lot of power, computational power, but some of them are very efficient, and efficiency is really the key in algorithms because they allow you to do lots of complicated um, a lot of complicated programs, a lot of complicated competitions, and ultimately you can use them in your products and other tools. Again, there's very cool applications of algorithms besides sorting numbers, which is relatively easy. For example, the Human Genome Project, it's a very big project. It has so much data, but a lot of these algorithms are very efficient in storing the data and analyzing data and ultimately, giving us either predictions or giving us some sort of output. There's like more than 100,000 genes that you might have to match and identify. It's very complicated, but again, these algorithms are very efficient for that, and that's the power of it. There's also really cool algorithms that, for example, search engines like Google and other tech companies use. For example, Google's search engine, there's so much results, so much data, so much information. Google has efficient algorithms for filtering them and identifying them to give you the best results. But ultimately, algorithms are, again, they take an input, they do some rules and competition and manipulation, and they give you an output. So it's essentially a sequence of steps if you boil it down to a couple of words. An algorithm is just a sequence of steps that a computer can understand with a programming language, and then they can execute. So that's the basic idea of algorithms.